For the assignment, I built a Python solution that predicts tea prices at the Colombo tea auction. Tea is one of Sri Lanka's biggest export earners. It is usually priced at the weekly Colombo auction. Prices can change a lot from about 520 rupees a kilo to over 6,700. Small scale sellers mostly price lots on experience and their gut feeling. So my goal was to predict a average price from data and to find out which factors actually drive it. I could use a public Colombo tea auction dataset from Hugging Face, built from weekly auction reports. The full dataset has over 12,000 price points. Since tea follows the seasons, I splitted the auction calendar into the 4 quarters of the year and focused on the first quarter, the January to March sales, which gives 2,809 rows. Each row describes the tea's elevation, grade, and quality tier, the weather in the growing regions for the 3 weeks before sale, and the rupee-dollar exchange rate. My solution is a straightforward pipeline in a single notebook. Loaded the full data, cleaned it, filtered it down to the first quarter, explored it with visualizations, then trained and compared 3 regression models, ending in one function that predicts the price of any user input Python dictionary of a data instance. The notebook loads the dataset with pandas using a Hugging Face access token. Actually, cleaning was more important than what I expected because 436 rows had no price, so I dropped them. The elevation column mixed 2 naming styles for the same thing. Then I pulled the sale month out of messy data text, which is also what let me build the quarter filter, which is a if-else-if function. Actually, functions, loops, and dictionaries do the work throughout with try except for error handling. I noticed that grown teas fetch the highest average prices. Feature importance analysis shows that quality tier, grade, and elevation drives prices far more than any single weather variable. Comparing linear regression, a decision tree, and a random forest on the Q1 data, the random forest won with an average error of about 48 rupees per kilo, roughly 4% of a typical price, and an R squared of 0.98. The charts showed that the quality factors drives price far more than weather factors. Limitations were that the Q1 data only covers 2 years and missing data for 2025. I also wish to repeat the analysis for the other 3 quarters and compare seasons. Full credits for the dataset, and I had AI assistance. Thanks for watching.